Hello, in this quick video we're going to be looking at an exam question. So we have data here for trend 1, which is the grey line you can see here. We're not going to be using trend 2 because it's exactly the same process, so I don't need to do it twice. But the question asks us to calculate the annual growth rate underlying the trend. So where do we start? Well, we can start by deriving our formula for constant annual growth, and we start with this, our standard growth rate formula, which is yt minus 1 on yt minus 1 equals g. That says the difference between today's output and yesterday's output, i.e. the growth, as a proportion of yesterday's output gives us our growth rate g. So with that we can manipulate the algebra slightly. We can multiply across by yt minus 1 and we get this, yt minus 1 equals g times yt minus 1. We can pop that minus yt minus 1 on the other side, so we get yt equals g times yt minus 1 plus yt minus 1. And if we just factor out the yt minus 1, we can just rewrite that as yt equals yt minus 1 plus g. Okay, so that's our growth rate. Now if yt is just output from the previous time period plus some growth rate, right? Just yt minus 1 plus some growth rate. What is yt minus 1? Well, it's just yt minus 2 plus some growth rate, right? I say plus some growth rate, I should say multiply by some growth rate. So yt minus 1, right? If yt equals yt minus 1 times 1 plus g, then yt minus 1 must equal yt minus 2 times 1 plus g. Hopefully that makes intuitive sense. So we can take this one here, I haven't circled that very well, but we can take that one and we can substitute in for the yt minus 1. We can substitute this in, so we can say yt equals yt minus 1, so I'm going to write it like this. I'm going to write it in brackets yt minus 2 1 plus g times 1 plus g. So this stuff inside the square brackets here, that is just yt minus 1. And so you can see here, well, you can see that that is equal to yt minus 2 1 plus g squared. And so we can generalize this by saying yt equals y0, that's our base here, times 1 plus g to the exponent t. So that is just a general version of this formula. We just generalized it, so for any time period, any number of time periods, you can just plug in the numbers. So that's our constant annual growth rate formula. Now recall that the question asks us to calculate the growth rate, so we need to solve here for g. So how do we solve for g? Well, we can divide across by y0 equals 1 plus g to the exponent t. Then we can go one step further by taking both sides to the exponent 1 over t. So put yt on y0, so the 1 over t equals 1 plus g. And finally, we just take away 1, so we get g equals yt on y0, so the 1 over t minus 1. So we've solved for g. Now all that's left for us to do, for us to calculate the growth rate, is to plug in the numbers. So what have we got? Up here we've got t is the number of years, so 1955 to 2006, we've got t equals 51. y0 is our base year value, so 2406 equals 2406. Yt is our end value, 7735. Okay. Now all that's left for us to do is to plug these numbers into our formula. Okay, so we've just plugged the numbers into our formula, which we've just derived. So yt 7735 on y0 2406 to the exponent 1 over t, so 1 over 51 minus 1 equals, plug this into a calculator, you get around 0.02. So that tells us our growth rate is, and that's not exactly equal to 0.02, but our growth rate is approximately 2% per year.